All right, so we got about 10 different things to take a look at today as far as how we can help determine if triangles are congruent. Okay. Some of these things are simple, some of them a little more complex. Okay, first one is what is referred to as the reflexive property. Okay, which states if two triangles share a side, okay, then those sides are congruent. Okay, notice that we have a example in red as well. Okay, so with these two different triangles, okay, since they both share a side BD, we know that BD is equal to side BD. Next one, okay, triangle sum theorem. Okay, so that's going to state that all interior angles of a triangle add up to equal 180 degrees. Again, something you probably already know. Okay, but in this example, we got angle X, Y, and Z that are going to equal 180 degrees. Okay, question on what are some of the symbols. First one up here, this just means side. Symbol in the middle here means congruent, equal sign with the squiggly line up top. And that symbol down there is for angle. All right, next one, again, probably heard it in some capacity, the Pythagorean theorem. Okay, the sides of a right triangle fit the equation a squared plus b squared equals c squared. Okay, where c is a hypotenuse. Okay, and a and b are the other sides. Little example over here on the left as well. All right, so a little more confusing moving forward. Okay, next one, vertical angles. So if we have two angles that are on opposite sides of intersecting lines, they are congruent. Okay, so you can think of it as two angles that are on opposite sides of an X. Okay, but anytime we have vertical angles, we know that they are congruent. All right, next one. Supplementary angles. Okay, you might have heard that term before. Could have been a while ago, but it's any two angles whose sum adds up to equal 180 degrees. Okay, they are supplementary angles. Okay, any angles that share a line are going to equal 180 degrees as well. So I got basically just an X again over there for an example. Also shows you how the vertical angles are congruent. Right, but A and C share a line, so they're congruent. A and D share a line, so they're congruent. D and B, B and C, same thing. Okay, so similar with complementary angles, or I'm sorry, supplementary angles, we have complementary angles. Okay, and those are just two angles that add up to equal 90 degrees. All right, one of the more confusing ones here, alternate interior angles. Woo. All right, so we can only use these whenever we have two parallel lines that are being crossed by another line, which is called a transversal. And the pairs of angles on opposite sides of the transversal, but inside of the parallel lines, are congruent. Okay, so hopefully the picture kind of helps clear some of that up. Okay, but anytime you have two parallel lines that are basically being cut by what is called a transversal, okay, opposite sides on the insides of the parallel lines, those angles are congruent. So here, angle A and B, and then C and D. All right, three more to go here. Okay, first one, definition of bisect. Okay, whenever you bisect something, you're cutting it in half. So an angular side that is divided into congruent parts. Again, anytime you bisect something, you're cutting it in half, equally in half. So in the picture, you got AD bisects angle BAC. So that states that angle BAD is congruent to angle CAD. All right, next one, definition of a midpoint. Okay, if you are given that something is the midpoint, it cuts a line segment in half. Okay, point in the middle of a line segment. So if C is the midpoint of BD over here on the left, then BC is equal to CD. And the last one, definition of perpendicular. Okay, so two lines that meet at a 90-degree angle are said to be perpendicular. Okay, that's a symbol we use over there. And anytime you have a perpendicular line, it's going to create two 90-degree angles. And when it does that, you know you have two angles that are congruent. So if they both equal 90 degrees, then you know that they are equal to one another.